Imagine computers that can unlock the secrets of life by predicting how proteins fold. Sounds like something out of a sci-fi movie? Well, it's real, and it's changing the future of science. Today, we're diving into a major breakthrough where artificial intelligence meets biology. Three brilliant minds, Demis Hassabis, John Jumper, and David Baker, were recently honored with the highest recognition in chemistry for solving one of biology's hardest puzzles, predicting and designing protein structures with the help of machine learning. What makes this achievement so exciting? It didn't just come from a university lab. This work originated at DeepMind, a tech company now owned by Google, proving that some of the most game-changing discoveries are happening at the edge of science and technology. Let's talk about proteins for a second. These microscopic machines do everything: build our muscles, power enzymes, regulate hormones. But here's the key: their shape is everything. If a protein folds incorrectly, it can cause serious health issues like Alzheimer's or diabetes. Decades ago, a scientist showed that a protein's amino acid sequence determines its shape. That was a big step, but even with that info, scientists struggled to predict the final folded form. That's where David Baker came in. He developed a program called Rosetta to help predict protein shapes. An impressive step forward, but there was still a long way to go. Then came AI. Machine learning, to be exact. Unlike traditional coding, machine learning lets computers learn by sifting through mountains of data. Demis Hassabis co-founded DeepMind, and under John Jumper's lead, they took on the protein folding problem head-on. Their creation? AlphaFold 2, a mind-blowing AI that can predict protein structures with unbelievable accuracy. It's already mapped over 200 million protein shapes, essentially every known protein on the planet. Why does this matter? Drug discovery. If we know a protein's exact shape, we can target it more precisely with treatments. Proteins have binding sites, tiny pockets where drugs can lock in and do their job. Knowing those shapes gives scientists a huge head start in designing effective medicines. And they didn't stop there. The next evolution of the tool, AlphaFold 3, can now also identify those binding sites, making drug development faster and more efficient. Meanwhile, David Baker's team created something even wilder, an AI method called family-wide hallucination. It allows them to invent totally new proteins from scratch, including some that glow. These synthetic proteins could do things nature never even dreamed of. And the impact goes beyond medicine. These engineered proteins could be used for creating biofuels, cleaning up the environment, or building materials that reduce waste. It's a huge step toward a more sustainable future. What ties it all together is collaboration. This isn't just about chemistry or computer science. It's about what happens when brilliant people from different fields work together to solve the impossible. So next time you hear about a new drug or a scientific breakthrough, remember, there's probably some incredibly smart AI and an even smarter team making it all happen behind the scenes. If you're loving this kind of content, hit that like button, smash subscribe, and stick around for more game-changing stories from the world of AI. Catch you in the next one.